welcome to the webinar. So we're here to talk about how to get started on Gaudi-based EC2 DL1 instances. My name is Greg Saraki. I'm part of Habana Labs application engineering team, and I'm here with Moet Diopujari, and the two of us will be taking you through some live demos, some explanation of the Gaudi architecture, and how to run workloads. So I'd like to start with a poll. So I'm going to try this on Zoom. I'm going to launch a simple poll. So all of you should see this poll popping up in your Zoom window. Two simple questions. One is, first, what's your experience with Habana Gaudi? And two, how did you find this webinar? So if you could please take a moment and fill out the poll, that'd be greatly appreciated. So we're here on Zoom, so this will be recorded and we'll post this on our Habana website for later viewing. We do have a question and answer section in the Zoom window, so you can start during the presentation. Please feel free to type in questions in the question and answer window, and we'll answer them live as we can, and then we'll have some time at the end to go through them specifically. Okay. And I see 76% of you have participated in the poll. So if you haven't, please take a moment and click on the poll. If you see the poll pop up on your window, please answer those two questions. Okay, and we'll let that run. Unfortunately, we do not have Habana Gaudi running in Azure Cloud at this time. So DL1 is our main partner from the cloud that supports Gaudi. All right, so let's keep going. So thank you all for participating in that poll. So what are we going to do today? I see from the welcome poll that 58% of you are a new user just looking to get started and get running. So this is perfect. This webinar is for you. Even for those of you that have read some documentation, this is exactly where we want to be. So this hour is really going to be for those that want to get started running Gaudi. So at the end of this hour, you're going to be familiar with what Gaudi is, how it's run on DL1, how to migrate your models over to Gaudi, how to use our model references, which are all of our pre-built optimized models, and then see the full power of the DL1 instance by running 8 cards. And what's new for this one is actually showing Gaudi doing inference. So not only can our device do training, it can also do inference. So we have a demo there as well. And then we'll do wrap up and questions. So again, the main objective today is just to get really comfortable with how to run models on Gaudi. Okay, so right now, Gaudi is instantiated on AWS, and the instance is called DL1. And so this instance has 8 Gaudi accelerators, and this is really optimized for high performance. So one of the things that the AWS team has emphasized here is 400 gigabits of instance networking across the node. Each instance has 4 terabytes of local NVMe storage. And the most important part here is that all 8 Gaudis on this instance are fully connected. So we have the dedicated 100 gigabit Ethernet ports. Each Gaudi is fully connected to every other Gaudi on the device, which is really a benefit for managing workloads and optimizing multi-card workloads. One of the key points of the DL1 instance and why it's here and why we've partnered with AWS is to give partners a choice, to give them an opportunity to look at an alternative to NVIDIA and other AI-based workloads. And this really provides the customer, in some cases, up to a 40% better price performance compared to existing GPU-based instances. So we really look to bring people into the instance to use this for a cost-effective alternative to NVIDIA and other solutions. Okay, so let's stop talking about it and let's just show it running. And so let's get this thing running in 5 minutes or less. So let's go to our quick start tutorial. And what we have here is a Jupyter notebook running on the DL1 instance right now. So this is live on DL1. And so we have access to a full DL1 instance. And this is a very simple quick start model that we took from the PyTorch website, to be honest. And we'll walk you through, in this case, the 2 simple lines of code that you need to be able to migrate your model over to run on Gaudi. So let's walk through the code. So at the beginning, we'll install Matplotlib, which is just a small requirement. And then here we're importing all of the required PyTorch libraries and basic model structure. So this is very boilerplate. That's done. Now, the most important part of this demo is this section right here. And so what we're doing here is importing the Habana PyTorch library. So we are now setting our own library, and the device is set to HPU. What is HPU? Habana Processing Unit. So you'll see in our code, we use HPU as a terminology to make sure that when you are running these workloads, that all the workloads here are default to running on Gaudi HPU, not on the CPU. So all of our code and our optimized models use this term HPU. So in this case, we're going to import the Habana library, and we're going to set the device to HPU. And that's done. In this case, this very simple model is using Fashion MNIST dataset. So we'll set the training data and test data. We'll download those. That's downloaded. And then we'll set the default data loader and a batch size. So now we've downloaded the data set, identified our data loader, and we now define our very simple model. You'll see here, this is a very simple, very basic model. And you'll see here when we print the model, we'll say using HPU device. So we know now that when this model is run, it's going to be run on Gaudi. Now, of course, to train a model, you always need a loss function and an optimizer. So we're setting the basic boilerplate things here for that. So cross entropy loss for our loss function and stochastic gradient descent for our optimizer. And then our training function is set here. And then our test function is also then set to test our model. And then in this case, now we are ready to run the model. And so we will run it. And now off we go. Now, as this is running, one thing that we can look at here is a tool called HLSMI. And I'll run this again. What HLSMI is doing is showing you the 8 Gaudi devices and their activity. And you'll see here in this case, we are using Gaudi 0 in our node. And this is running the Python script to run the model. And you'll see it running the workload. And in this case, since we set 5 epochs, we look through this and we see the 5 epochs have been completed. So what you can see here is that with just a couple lines of code, we're already migrated a model and we're already running on Gaudi. And we'll talk about TensorFlow in a moment as well. Okay, so again, when we are getting started, there are, in recap, a few very simple things to do. First, importing the Habana frameworks, PyTorch models or PyTorch library, setting your device to HPU. And one additional thing here is the way that we have an optimized run for the most efficient run, for the best performance and lowest time to train, is we basically collect ops and run ops and graphs as needed. So what our library does is collect a larger graph, and those graphs are only called and run when needed. So instead of running every single graph sequentially, which is not efficient, they're only run when needed. And there are two key points when those graphs are optimized and called, and that's after a loss function and after running an optimizer. And you'll see this function called htcore mark step, or this mark step function. So all we need to do is simply add this mark step call after your loss function and after your optimizer step. So these 4 lines are the main areas you need to get started running with PyTorch. Now, there's a question from the chat. What about TensorFlow? Well, we have you covered. So in TensorFlow, it's a little bit different and actually quite a bit simpler. So in this case, we're simply loading the Habana module. So we have a library called load Habana module, which is built into TensorFlow. And you call that function. And that step initializes Gaudi, sets the Gaudi HPU as the main device for operation, and then all the workloads then will run directly on Gaudi. So again, very, very simple to do. And the details of all of this also are obviously included in our documentation. All right, so let's talk about how we scale out. What are some of the specific use cases that are really applicable? Because that simple model will get more and more complex as we go through the presentation. But let's just talk about some of the focused use cases that we have. So obviously, computer vision and natural language processing right now are the big ones. We look at all the standard computer vision workloads. We'll show you in a moment our model references GitHub page, where we have a large variety of computer vision models. In addition, natural language processing. We look at all the question and answer, sentiment analysis, text generation, translation, not only on our traditional BERT models, but now we're looking at, we support deep speed. So we have a 1.5 billion and a 5 billion parameter deep speed model that we've already optimized. And we're looking at larger GPT-2, GPT-3 style models, leveraging Bloom and Hugging Face and other models to get larger and larger, the largest NLP models. And then finally, multimodal is really this idea now that we're mixing text, speech, vision, all these things coming together to work together. And so we'll see later today a demo on Stable Diffusion, which is a text to image generation use case. And we have partnerships with many of these companies down below in the verticals. So you may have seen in the press our engagement with Mobileye, with Leidos, several other companies to showcase some of these workloads and use cases. Okay, so let's talk about some more specifics. We showed you a very simple model to get started, but now let's get into some specificity about, what are some models and what can you do to start using Gaudi yourself with some real world models. So let's talk about model references and go to that GitHub page. So this is our GitHub page, and you'll see here we have over 50 models that have been validated and fully optimized to run on Gaudi. And this includes a mix of computer vision for TensorFlow and PyTorch, natural language processing, again, for TensorFlow and PyTorch, including that deep speed 5 billion parameter model, recommendation systems, wave to vec, and generative models. So these now are all the rage in the press, where you can type in an instance, a query or a prompt, and have a video or a picture generated, and we'll see that in just a few minutes. So when we look at any one of these models, you can click on any one of these, and let's look at, for example, BERT fine-tuning. If we look at BERT fine-tuning in any one of our models, we have a full set of instructions that show you step by step how to download and run the models. Now, in this case, we know that BERT itself was pre-trained on the Wikibooks corpus. And so for this fine-tuning example, we can either look at the MRPC dataset or the squad dataset as two examples that we have. So we'll do squad in just a moment. The key point here is that this shows you how to do the setup and gives you training examples. And so it's very simple. For those of you that want to start running a BERT model, all you need to do is come down here and select an option that you'd like. And so this gives you all of the requirements and setup needed to set the hyperparameters, set the training parameters, and all the steps that are required to get the model to run. So in this case, we are going to do this example here. So we're going to run BERT large fine-tuning with the squad dataset using bfloat 16 mixed precision and one card. So let's jump back over to our notebook. And we will come back here to this. And so all we've done here is made sure that we carried over the requirements to set our environment variables, set our path so that we are in the right location, install a few of the associated libraries and requirements that are needed. And let's remember that this example is using the Hugging Face BERT model. And one of our key partnerships is with Hugging Face, where we are ensuring that now almost 40,000 of their transformer-based models are running on Gaudi. So in this case, we will install transformers, which is the Hugging Face transformer library. And now we'll simply run the script. So this is exactly the same runtime that was shown on our model references GitHub page. And we will let this run. So again, this is doing a training, fine-tuning of the squad dataset on that existing BERT model. And the other thing to add here, let's kick this off and let it start running. There is one key thing here when we call our model scripts, which is this command called use HPU. So if you remember that in our previous model, we were setting the device to HPU. So in this case, when we want to make sure that HPU or Gaudi is being used, we always send in this flag called use, use HPU. And again, this ensures that all those models are running directly on Gaudi. For the rest of these, you will see that these are fairly standard hyperparameters. So we're setting the dataset name. We're using some of the optimizers. We have sequence length, learning rate, number of epochs and steps. And then what Moet will show us in the next example is the details around Habana mixed precision. So in this case, we are also setting the HMP or Habana mixed precision flag. Okay, so while this is running, let's take a step back and talk about the architecture. Okay, so that demo is running. So let's talk about the hardware and software. So let's look inside the Gaudi chip. What's inside? Let's remember that Gaudi is not a GPU. Gaudi was designed from the ground up to be a dedicated deep learning training and inference processor. So it is specifically designed to run deep learning workloads. So a couple key points here are the 8 tensor processing cores. So these are all optimized to run all of the ops, either broken down from TensorFlow or PyTorch, our matrix multiplication engine, and our high bandwidth memory. So in this case, we have 32 gigabytes of high bandwidth memory. And the one thing that really is a differentiator here between the competition is our onboard 100 gigabit Ethernet ports. So we have 10 100 gigabit Ethernet ports built into every Gaudi device. So as we showed you the diagram at the beginning, on our DL1 instance where there are 8 Gaudis, all 8 Gaudis are fully interconnected over this 100 gigabit Ethernet port. And then to scale out of the chassis, to scale to multiple nodes where you're running 16, 32, 128 Gaudi devices, then these connections can be used to manage scalability across the node. And again, when you use a DL1 instance, you're getting access to 8 Gaudis. So this is a really high performance, high capacity instance in AWS. Then we look at the software. You'll hear us use this term Synapse AI. So Synapse is simply the name of our software suite. And this is a shared software stack that supports both training and inference, and is fully integrated with PyTorch and TensorFlow. So the key point here is that this entire software stack is designed to migrate and manage PyTorch and TensorFlow workloads. So as I showed you in the previous slides, there's minimal steps required to migrate your PyTorch or TensorFlow models over to work on our software stack. And again, requires minimal code changes. So once your model is running, we have a bridge that converts your PyTorch or TensorFlow instructions into Synapse AI software stack. And a couple of key things to note here are our graph compiler, which is again used to optimize and ensure that the workload is running efficiently on our hardware, and then our HCL or Habana communication libraries, which is required to help manage the distributed computing. So this is running all gather, all reduce, those commands to make sure that we are optimized across card or across node. The customer has the ability to write their own kernels. So we have a set of tools and capability for customers to write their own kernels to do that fine tuning of their model. But we have a broad, extensive kernel library and a broad set of ops support across PyTorch and TensorFlow. And all those are obviously documented in our documentation. And then finally, to pull all this together is both Habana and AWS offer a set of Docker images and deep learning AMIs or deep learning Amazon machine images at the AWS marketplace. So we have pre-built PyTorch and TensorFlow Dockers. AWS provides some quick start images. So it's very easy for a user to start with. If you're running a Docker, you can just simply take our Docker image that has the full software stack already loaded. So from a user perspective, all you need to do is stand up the DL1 instance, load our Docker image with PyTorch or TensorFlow, and you have everything you need to start running workloads. And again, you can run them directly from our model references or start to migrate your own models. So speaking of running from model references, let's take a look back at our BERT fine-tuning and see what happened. So in this case, as we started the fine-tuning, we will remember that we're taking the BERT model and fine-tuning it with a squad data set. So let's see what happened. So in this case, we're bringing in all the data from Hugging Face, including the initial weights from the BERT-based model. And then we are training the model. So you can see now that we're fine tuning the model. So we see now the loss is continuing to go down. The learning rate is continuing to become more refined and more specific until we get to the end where we have a nice loss function here of 1.5. And the model now has been fine tuned. And that took only 2 minutes, 1 minute and 54 seconds. So this is a great example of how quickly and easily it is to take a model, pre-trained, fine-tune it, and now you have the ability to use this in a chatbot or a translation model or other use cases. And all that was through a few clicks from our models and definitions and directions already in our GitHub page. Okay. So now let's continue to drive innovation here. Let's take a look now at what it takes to fully utilize the full DL1 instance and run this workload across 8 Gaudi accelerators. So I'm going to give the screen and the microphone over to Mohit, and he'll show us that demo.
All right, thanks, Greg. Hello, everyone. Good morning. My name is Mohit, and I'm a deep learning software engineer here at Habana. And I'm going to show you what Greg just mentioned, running a very simple image classification model on 8 HPUs, 8 Gaudi HPUs. So let's see. I hope you guys can see my screen. Let's move it around here. Okay. Perfect. So as you can see, we're going to run ResNet 152, the image classification model, based on PyTorch, and we're going to do multi-card training this time. We have one DL1 instance here with 8 Gaudi HPUs on it, and we're going to run this training on all those 8 nodes together, 8 cards together. So one quick important thing here is that we are going to use Habana Mixed Precision. What is Habana Mixed Precision? It's basically a package that allows you to use both 16-point floating point and 32-bit floating point together in your model training, and that speeds up your model training at the very less cost of accuracy, but also uses less memory. So it makes your model training more performant without sacrificing any of the accuracy. So this is how we do it usually. You can run this 2 lines here anytime before running the training loop. It's very simple. It's coming from the Habana frameworks library that we have in our PyTorch image. And you just import this HMP package, and all you need to call is hmp.convert. And that makes this into a mixed precision training. Moving on. So we need 3 things to make any kind of training from a single HPU training to a multi-card HPU training. And these are the 3 things that you'll need. First of all, you'll need the HCCL package, which is the Habana communications library. And that allows you to be able to intercommunicate between the different cards. And even when you're using different instances all together, like you have, let's say, multi-card and then multi-node, which is different instances, it all handles the communication between that. And this is how you do it, this chunk of code here. So you're just importing this library and initializing it. And you just initialize it here. The next point is using the Torch distributed data sampler. So since we are doing multi-card training, your data sampler needs to be wrapped around with a special kind of a distributed sampler that allows your data set to be spread across the different cards. This is how you do it with this simple line. You just wrap around your regular data set. with this Torch utils data distributed sampler. And that's it. That makes your data set distributed. The third point, we're going to do the model initialization in a data parallel way, a distributed data parallel way. And how you do that is you have your model, a regular model. You just wrap it around using this library here, which is coming from the Torch package itself, distributed data parallel, and that's it. Now your model becomes distributed as well. So let's see the live demo now. We're going to need some environment variables, which is specifically, we're going to point to our classification library here. I mean, the path for where our training script resides. So let's set that. And we're going to cd into that path again. We have that as part of Python path. Let's cd into that. And the next one, this is the command that we're going to run for it to be able to run in a distributed fashion. We're using MPI run here, and we are using 8 cards. So we specify that in this flag here, -m8. And this is our training command, which is the regular training command. It starts from here, Python train.py. Our model is 1152. So let me just go through that and run this script here. This whole thing is packaged in a shell script, and we're going to run that. As you can see the same message being transmitted like 8 times, which is because it's coming from different cards. These are the initialization messages. So here you see the distributed init. It says around 0, 1, 2, 3, all the way through 8, through 0 to 7. So there's 8 cards. All of those have been initialized. Now it's loading the data. It's loaded the training data. It's loading the validation data. It's created the model. Beginning training. Very shortly, you'll see the epochs and the progress showing up. Meanwhile, let's go back to the command that we just run and explore it a little more. So as you see, we've used the device equal to HPU flag, which specifies for the training script that, hey, we are targeting the HPU card. We are also using the HMP package, which means Habana Mixed Precision. And with this package, you can specify what specific ops you would like to use mixed precision training with. You can even specify certain ops in the model that you want to be run using either BF16 or FP32. And that's the kind of granularity you get with this package. So yeah, these are the most important points here. And you already seen that we've targeted 8 cards. That's why MPI run is being used with 8 cards. So MPI run helps us to run this training script across all cards together. Now you see the epoch progress meter is showing up. First step has happened. There's another step will be coming up shortly. Meanwhile, you can go and look at our system, simply running HLSMI command to show the state of our cards. And that shows all 8 cards are busy. You see the memory usage. These are the 8 processes running on all the cards, 0 through 7. It's running the same Python training process, and they're pretty much using the same kind of memory across. And so the training continues. You see they moved on to the next epoch, and we're getting this kind of data here. So in this quick workshop, what we've seen is we learned about Habana Mixed Precision usage and why it is important. And we also showed you how to transition to a distributed training from a simple model. You just use distributed data parallel packages. You wrap the data set, you wrap the model, and then you're ready to go. After initializing the Habana communication library, you're ready to train it across multiple cards. So we'll let this training continue. And I'll show you another quick inference video. This is one of my favorite demos here. Here, we're going to run inference. And this is only Gaudi again. We are going to do some image to text generation, which is really hot and popular these days. So let's do that. So we already have set up the script to run inference as part of our model garden. So that's where we're going to CD into that path using stable diffusion model here. This command here is to set up the Git's permissions and also to set up the requirements. I've already done that before. So you would need to run this to have all the required libraries and packages. So now let's enter an input prompt for the model. I'm going to say, let's something wild here. Let's say elephants on a cycle juggling. Okay. And that's my input prompt. And we're going to run this inference using this prompt here. So let's do that. It takes hardly a minute to run this inference. And we should be able to view the results using this piece of code down here. So this is the initial code, initial messages that the code is sending out. And now here, we're going to run the inference. We already have the model checkpoint downloaded. And we're using that pre-downloaded model checkpoint to run this inference. Yeah, this is the most waiting part because you never know what the images are going to look like until the last minute. There we are. It's going to tell us that it's done preparing the images. All right, we produced our samples. It's going to produce a bunch of images, which we specified here in the command. You can change the command here. For example, I specified like n samples as 4 and number of rows is 4. So it's going to show 4 samples per row. So it's going to make like 16 images based on that input prompt that I asked for. And let's look at the results now. Elephants on a cycle juggling balls. I guess I made a typo there. So this is what you get if you do a typo. But yes, you see elephants on a ball at least. So that's a very simple demo there. And I'll hand over to Greg.
Okay, excellent. But thank you so much for showing that. So let's finish out the slides. And I think the key thing here is, in summary, we've shown you from the broad to the specific, right? How to do the basic migration, the steps to do the migration, and how to run basic models from our models references, and some more detailed examples of training 8 cards and inference as well. All these models are available on our model references. So really, we want people to continue to get started and take advantage of the capability and the power of our Gaudi devices on DL1 Instance, and really take advantage of these use cases that we're providing. So we recommend people continue to use our model references webpage and GitHub page to to start playing with the instance and get familiar with it, and or migrate your own. And we have a set of videos, our developer website, our documentation, and we talked about the model repository. Again, we talked about previously the marketplace. So we have our base images with the Synapse software stack, and Docker images with TensorFlow and PyTorch support. And for those that want to continue to engage after today, our user forum is also available for people to post questions and engage directly with us at Habana if you have questions. Okay. So that concludes the presentation. So we have right on time. We have about 15 minutes remaining for Q&A. So so Moed and Hen also. So I'd like to introduce also Hen Lefkovich from our team, from the product team. So we're here to. Hi Hen, thank you for being here with us to answer some of our questions. So we will go through the question and answer. Now, I was trying to answer a few of these before as we talked. So there was a question about Keras plugins. So Vijay, I just sent you a link in the chat for the Keras APIs we support. There's Stefan asked a very good question about just bringing models in general. And the question was, do other models in general work as well, despite not being validated and optimized? And the answer is yes. In most cases, our objective is to get really any model to work. And if there's an issue with a specific op or function running on Gaudi, then in most cases, it will default back to the CPU in the server. And so again, we want every model to run and not crash. And in most cases, we do see that there is at least a model will run, and then may require some additional tweaks for final performance. But in most cases, we do expect to see models being functional. Okay, and then Stefan asked another question around Hugging Face. Do all Hugging Face models run or only transformer-based models? Our initial focus and engagement with Hugging Face was really around transformer-based models. And I provide the link to our Habana sit page on Hugging Face website. So what Hugging Face has done is created their own Optimum based library. So they have their own libraries that are used to optimize on specific pieces of silicon. And the Optimum Habana library is one of those. And so our engagement with Hugging Face at this point, they're telling us that basically 40,000 models are available and should be running on Gaudi.
Yeah, they just recently also enabled for themselves the diffusion models, and I believe it's also running on Gaudi. Yeah, so.
Yep. So really, the engagement with Hugging Face just continues to expand, and you should feel comfortable. What they've told us and what we've tested is, you should be able to be comfortable running, multiple Hugging Face models on Gaudi. Okay, Vijay asked a question about multi-tenancy. So how is multi-tenancy handled? Well, today when you use the DL1 instance, you get access to all 8 Gaudis. There is no path at this time to be able to only rent 1 or 4 or a subset of those. So as you rent it, you get all 8. Now, once you have access to all 8 of those Gaudis, there is some ways to set up access to only 1 or 2 or 4. So within your team or your group, you could share that DL1 instance and only allocate a subset of those 8 cards. And I provided a link in the collateral to show how to do that. So we have the ability to do that. Okay, so back to some of the open questions. How do we do hands-on, and what's the price of each HPU? So Manish asked this question. So today, for most people, the best and fastest way to get access to the Gaudi is through AWS and through the DL1 instance. It's the on-demand price is about $13.15 an hour, which is again significantly cheaper than comparative P3 instances running NVIDIA GPUs. There are so in most cases that's the fastest way to get started. We do have partnerships with Supermicro to sell a full box server. So if you're a part of a larger company that wants to invest in Gaudi and have it on premise, we do have partnerships with Supermicro to purchase a dedicated server. We do have partnerships with San Diego Supercomputer. They are running a full fleet, a data center of Gaudi devices. But in this case, if you're part of a larger business and would like to set up a business relationship with us to get access to Gaudi, we do have a path there as well. But you can reach out to us through our website and get involved with our business team to see if there's a business appropriate case to provide access to Gaudi. But for those individual contributors, DL1 is the best way to get access. Okay, so a question from an anonymous attendee: how does the distributed example change if I want to run multiple 8-node Gaudi? So in our collateral, we do have a path to show how to do that. So in our documentation, you can see distributed training with PyTorch. And in this case, we walked you already through, Moet walked you through the initialization steps here that you see. And again, this simple example here that that we use is basically similar to what Moet showed you. When you look here, there is a scale out across servers. So we do have the way to set up an MPI run command and scale across multiple servers here. And I will put this link in the chat. Okay, so Alexander asked a question around the HPU load. So I think this is with respect to the HLSMI. So the HLSMI is really a snapshot. It's not necessarily a real-time measurement of the workload. So depending upon when you're initializing and running HLSMI, you'll see the HPU load being a lower percentage number or a higher percentage number, depending on when you initiated the command. Okay, Hussein asked a question around what does workers 10 do here? I'm assuming this is with our run on the ResNet 152.
Yeah, with workers 10, I think it's for the data loader workers. So you can specify the number of data loading processes that you want to be running to run together to do the data loading. This has nothing to do with the training workers per se, because we are using 8 HPU cards, so we cannot do it 10 anyway.
Okay, Dan asked the question about how many cards did Stable Diffusion use? So in this case, the model here, we have that running just on one card.
That's correct. Just one card.
But from an inference perspective, we have the ability to scale that up and run multiple cards if we wanted to.
Mm-hmm.
Okay, so Alexander is asking a question about stable diffusion and a comparison. It's, you know, we can't necessarily compare this. There are several things that define performance time here in terms of how long it takes to generate these images. So it's really not reasonable to compare the timing here on a laptop-based GPU versus Gaudi. But you know, the timing here is, again, 4 images in 50 seconds. And you're seeing that it takes 5 minutes plus for 5 images on your laptop. All we can do here is just say that, you know, on our system, it takes that 50 seconds. Okay, Dan asked the question, can stable diffusion inference run on a single HPU? And in that case, the demo we showed you exactly did. Again, in this case, because of the way that AWS has defined the DL1 instance, you get access to all 8 Gaudis. In this case, the example and the model we ran is just running on 1. Okay, VJ asked a question about other cloud providers, and I think the broad answer is yes. We have desire to scale across multiple cloud providers, but right now our main cloud provider is AWS. Okay, Stefan is asking the question around Hugging Face Optimum Habana documentation lists single card only for supported frameworks. Does this mean that multiple accelerator or multi-node support is still missing for Hugging Face? We've been working with Habana, with Optimum and Hugging Face across 8 cards and longer. I'd have to go back and look. Say again, what?
We've also done multi-node, so we do support multi-node and multi-card both with Optimum Habana.
Yeah. Maybe leftovers from documentation, like for sure it support multi-node and multi-card.
Yeah, I mean, all the models that they've tested with us is using, you know, even testing deep speed, which is again multi-card and multi-node. So Stefan, I'm not sure exactly where that is, but we do support scale up with Hugging Face. Okay, and then Chen, you're typing an answer to this anonymous question around exporting to standard formats.
Yeah, basically it is supported, of course. This is a framework function. Yeah, so you can train on Gaudi, export to different formats, and inference on other devices if you need to.
Absolutely. And so, Alexander, in terms of how we measure, you know, the output, you know, it's really depends on the start and stop, and again, requirements upon network latency and some other things. So, you know, how you measure the execution of the workload would really be dependent upon your specific use case. Okay, we've got about a minute. Again, for those of you that would like to continue to engage, I'll point you to our forum. So forum.habana.ai. So you have the ability here to come in and ask any sets of questions around training or inference. And this is a place for you to engage with us and continue the conversation. Okay, so as we end the event here, thank you all for participating. The great turnout, and we'll have a small survey with a few questions here at the very end. So as we stop the class, you'll see a survey, and we'd love to hear your feedback. So again, everyone, thank you for participating. Moet, Chen, Pauline, thank you all for being with us. And we'll call it a day. Okay. So thank you to everyone.
Thank you.